Okay, so welcome everyone. My name is Mark, and I will be your teacher of today. So what we're going to discuss is week 1 from business mathematics. Um, so we will spend a lot of time on the summations and products. Then we will do some powers and logarithms. And if we still have some time left, then I will also discuss the sets. And I think that's probably what we can do today. So this is recorded. You feel free to open your webcam or to interrupt me if you want to ask a question. You can just turn on your microphone, but just be aware that you are recorded. So it's perfectly fine if you decide to leave your camera off. But I just want to say, feel free to always interrupt me if you have a question. You can use your microphone or you can use the chat. I personally prefer the microphone, but if you find it a bit scary, it's fine if you do it via the chat. Okay, so let's get started. I will also sometimes call your name and I then might ask you a question, just so you know. Okay, so let's get started. Week 1, the summations. So a summation is just a really efficient method to sum up some numbers. So let's say I have this index letter I, and then here I will write down the starting value. So for example, 1, the most easy example. And then here I will write down the ending value, for example, 3. And then here we will put some expression. It can be anything. It can be 2i plus 1, I squared, or just simply I. And then what you're going to do is you're going to look, okay, what's the first value that I will be? Well, that's the 1. Then it will make steps of 2, like this. Sorry, steps of 1, this. And then because we have a summation sign, we get pluses in between, like this. Okay, if I is 1, then the value of my expression will also be 1. If I is 2, then the value of my expression will also be 2, etc. So this gives us 6. So let's do a more difficult one. If the summation, starting value will be 2, ending value is 4, and now the expression will be 2i plus 1. Okay. So again, I start by writing down which values the I will be. So I will be 2 here, not 1, because the starting value is 2 now. Then it makes steps of 1. So we get I is 3, I is 4, and there it stops because the ending value is 4. Because we have a summation, not a product operator, we will get pluses here in between. Okay, then I will look, okay, if the I is 2, what will be the value of my expression? Well, that will be 2 times 2 plus 1, which is 5. 2 times 3 plus 1, which is 7. 2 times 4 plus 1, which is 9. And that's how you can solve the summations. So 7 plus 9 is 16, plus 5 is 21. Okay, so let's do another example. I is 2 all the way up to 4. And we will put a 10 here. Okay, so notice that we're now working with a constant. There is no I in the expression. So what you will do is you will still write down I is 2, I is 3, I is 4, and then you put a plus in between. So if the I is 2, then the value of my expression is still 10, right? If the I is 3, then the value of my expression is still 10. If it's 4, it's still 10. So we get a 30 here. So we are still using the i's to know how many 10s we need to sum up, right? And that's what we're doing here. Okay. Then I will ask one of you to help me. Feel free to help me answer it. By the way, do you guys hear me clearly? or is there sometimes an error or something? Just let me know. Could somebody say if you can hear me
Yeah,
clearly?
it's clear.
Yeah, we can hear you.
Okay, great. Let me know if you sometimes if there's an error or if I'm lacking or something. Okay. So here's another one. I is 2 all the way up to 5. 2I plus 2. Okay, who likes to help me with this? Maybe you, Charlotte? Would you like to help me? Or maybe someone else? Maybe you, Niels?
Yeah, sure. It's 2 times 2 plus 2, 2 times 3 plus 2, 2 times 4.
Sorry, 1 second, 1 second. What is the first value that I will be?
Oh, 2.
2, and then it will become a 3,
3.
right?
Yeah,
And then it will become
4.
a 4, and then
And
it
5.
becomes perfect. What kind of signs will we put in between? A plus?
No, times.
Yes, because we're now working with a product operator, right? Okay, and what did you say? If the I is 2, what will become the value of my expression?
2 times 2 plus 2,
And that is?
6.
Very good. And if the I is 3?
8.
Very good. And if the I is
10.
4? And if
And
the I is
12.
5? Very good. Could you plug this into your calculator, see what you get?
Yeah, sure. It's 5,760.
Okay. Thank you very much. All right. So this was just the introduction. Is this clear for everyone? Then we will start by doing some exam questions.
Yeah, clear.
Great. Okay, so what you're seeing here is you have to calculate this product. So I will write it down. The index letter is k. It starts at -1. It goes all the way up to 1. And then for this x that you're seeing here, you can substitute this 2 with the power of k. So this is basically what you need to calculate. So what I will do is I will ask you a question via the chat. And then in this chat, you can send your answer with a private message. So do it with a private message so that not the other students can see your answer. And then if I see that the majority submitted his answer, I will discuss the exercise. Very good, Bo. You were really fast. You also have it correct, Jelte. I see a lot of zeros. The answer is not 0. Kamal, Thomas, and Edwards, you might want to recalculate your answer. Yes, very good. So I already see a lot of correct answers. Niels, you also made a small mistake, I think. Okay. Betty, would you like to help me to solve the question? You had it correctly. What is the first value that k will be?
Do you mean me?
I actually meant Patty, but it's also fine if you want to help me. Pere. How do I
Oh,
pronounce your
okay.
name?
Well, I don't know. Better, yeah.
Pere. All right. So what's the first value that K will have, Pere?
-1.
Yes. And what will be the next value?
0,
And then?
1.
Yes. What kind of sign will we plug in between?
Times.
Yes. So we get 2 with the power of -1, 2 with the power of 0, 2 with the power of +0.
Yeah.
What is 2 with the power of -1?
0.5.
Yes, very good. And for the people that didn't know that, it's this rule, right? If you have, for example, x with the power of -2, you can write it down like x with the power of a +2. Okay. And what it will be 2 with the power of 0?
Is 1.
And 2 with the power of 1?
That's 2.
Yes. So what was your outcome?
1.
Perfect. And that's the correct answer, 1. Okay. If there are no questions, I will go to the next one. And thank you very much. So here you need to calculate this thing. And for x, you will insert k. So you're working with a constant called k. And you probably cannot read this yet, but don't worry about this part. It's just to be precise, but you will learn later today how to read that. And also don't forget to simplify your answer. Okay, so if you have it, you can submit your answer. So Thomas asked the question, isn't it 1 because we divide the same thing as the upper side? No, because in the upper side we have a product operator, and in the denominator we have a summation. So yeah, no worries. Think almost everyone submitted his answer. Don't forget to simplify. That's what I want to say in general. Okay. Bo, would you like to help me to answer this question?
Yeah, sure, but I didn't know it, so I have no idea.
Okay, let me help you. Do you know what the first value of j will be?
1,
And the second value?
2,
And the last value?
3.
3. Okay, great. What kind of sign will we have in between in the numerator?
Times,
Yes. And in the denominator?
plus.
Yes, very good. If the j is 1, what is then the value of this expression?
Yeah, that was a thing I didn't understand.
So do you remember the example with the 10? Then I said, if j is 1, what is the value of the 10? Well, it's just 10, right?
Oh, okay, yeah, then it's just k.
Exactly. And if the j is 2, what's the value of the expression?
Okay.
Also
Yeah.
okay. And
Yeah.
if the j is 3?
Also.
Yes. And the same holds for the denominator, right?
Yeah.
All right. Then k times k times k is the same as?
K to the power of 3.
Yes. And k plus k plus k?
3k.
Yeah, very good. Is this your final answer? Or can we simplify it a bit further?
You can simplify it by doing k to the power of 2 divided by 3.
Yes, very good. And then this is your final answer. So very good. You did know how to do it.
Yeah.
All right. Is this clear for everyone? Very good. So now we're going to the next topic. And this topic is about the properties of summations. So the idea is that some summations are really difficult or really time consuming to calculate with the previous method we used. Sometimes you need to use some properties. And I will walk you through all the properties except for the additivity, because that one is pretty straightforward. So I will start with homogeneity, and then I will discuss all the properties about summations. Okay, the first one, homogeneity. So the definition of homogeneity is that you have a summation, and it has this structure. It's a constant times some expression. And I will give an example, obviously. And according to homogeneity, you can simply put the constant in front of the summation. Like this here. Okay, so let's do an example. I will show you with an example that this really is the case. So let's say we have 2 times I. Then the 2 is my constant, right? And the I is my expression, but the expression could also be more complicated. Okay, what I'm going to show you with this example is that this will be the same as putting the 2 in front. So here we go. Okay. Do you guys agree that I can write this down like 2 times 1 plus 2 times 2 plus 2 times 3? That's what I can do, right? Here the I is 1, here the I is 2, I is 3. Here you can see it. Right? Okay. What you will now see is that all the 3 terms have this 2 in common. What does it mean? I can get the 2 out of the brackets. So I can write it down like 1 plus 2 plus 3, like this. This is the same as 2 summation I is 1 all the way up to 3 I. And here you go. So now I've shown with this example that the property really works. So if you have a 2 like this, a constant, you can simply put a constant in front of the summation for in the future. Okay. So I will just show you the properties like this, and then I will give you some exam questions where you can apply them. Okay. The next one is the extending terms property. Here you can see it. The third one is the extending terms property. That one is maybe a bit more difficult. Extending terms. Okay. The property is as follows. You have a summation starting from I is 1 all the way up to n. And here you have some expression. And you can add another summation, but this summation needs to start one step ahead of where the previous one ended. So this one ended at n, then this one starts at n plus 1. So if you have a 3 here, you will have a 4 here. And then here you will have some big number, n plus m. And according to that property, this summation, those two summations added together, are the same as this summation. I is 1, n plus m xi. So I'm going to show you with an example that this really is the case. So here we go, example. Let's say we have this summation. It starts from I is 1 all the way up to, let's say, 3. And then the expression will be I. And then here I have a summation. Where does this one needs to start according to the property? It needs to start at 4, right? Because if the n is 3, then n plus 1 is 4. Okay. And then here you have a 5. So this should be equal to each other. We're going to check that. Here, by the way, if you see a 5 here, then this should also be a 5, right? It's both n plus m. Okay. So let's see if it really holds this property. Why 5? Well, this 5 was just random. So this one I just chose, but this then also needs to be a 5, right? Because they both are n plus m. They're the same. But the 5 was just random. I gave it to you. Okay, so let's see if those two sides are equal. So the left summation is 1 plus 2 plus 3, right? And the other summation is 4 plus 5. Maybe I can add some brackets. So this is the left summation, and this is the right summation. And what you will see is that this is equal to 1 plus 2 plus 3 plus 4 plus 5. Oh, I see something in the chat. Yeah. So indeed, the n is 3, but the m is 2. But that was just I could also have given you some other values for n and m, right? So I just gave you a random 5, but it could have been also a 7, for example. It was just I decided to make it a 5. You couldn't know that yourself. So okay. So now you're seeing that this really holds. So now you can see this property works, right? Okay. So now is the question, what can you do with it? Well, just to give you something to think about. Here, the property was perfect. You could apply it perfectly. But on the exam, maybe they don't give you a 4 here. Maybe they give you a 3 instead. And now you get a problem, because this summation includes a 3 here. But now you will see that also this summation here will include a 3. You will get a 3 like this. Maybe I can write it down. So you get a 3 here as well. What does it mean? It means you now have the 3 twice on the left side. And that's a problem because then the two sides are not equal anymore. So just to give you a way to think about this, you now need to subtract the 3 to correct for it, like this. So the first thing you need to know is this property. You just need to learn it by heart. But then on the exam, you also should be able to make corrections on it. Because here the property is not exactly holding, because actually we need a 4 here, but there's a 3. And then you should see on the exam that you have to make a correction, that we have the 3 twice, and that you need to subtract the 3 to make it equal again. So that's one thing that you can get. So this includes the 3, this includes the 3. So I need to subtract the 3 to correct for it. Okay, so here's another one. Now I'm back to the normal situation, right? This is how the property should be. I'm making another one. I should have a 3 here, but now I only have a 2 here. What goes wrong? You can just turn on your microphone if you know what goes wrong here. Why is it not equal to each other?
The tree is missing.
Exactly. The 3 is now missing, right? Because we don't include the 3 here anymore. So we skip the 3. How could we correct for it to still make the both sides equal to each other?
Maybe a +3.
Yes. You just do a +3. And then you still have it, right? So you need to be a bit flexible with the property so that you can make some corrections to it. If you skip something, you just add it to make it work again. That's the thing I want to show you here. You will see what I try to do here with the next question, but then I already said it. Okay. So that's the extending terms property. By the way, I normally get a question about the brackets. So maybe one of you guys is thinking this. What is the difference between having brackets here that the 3 is included in the summation or that the 3 is not included in the summation? Maybe it's good to go through that. 1 second. Okay. So a question I get pretty often is this here. So you have a summation. Like this. Or you have a summation like this. What is the difference? So here we do have brackets, here we don't have brackets. Well, the difference is that in the first equation, the 3 is part of the summation. And in the other one, the 3 is not. So here you will get 4. Here you get 5. So you end up with 9. You see that? But here you first do the summation, and then when you're done, then you add a 3. So you do 1, 2. So that's 3, that's the summation. And then we add a 3. So here we only get 6. So the brackets are important here. Okay, so that's a question I got pretty often. Because now I guess you don't ask it because it's online, but normally I teach this class in person. So also the future sessions will be at the VU, just in a room, not via Zoom. And then I often get this question, what's the difference between the two summations? Okay. So here I didn't include the 3 in the brackets, right? So it's just 1 3 that I add. Okay. So that's the extending terms property. Any questions? No? Then we go to the next one. Constant term, one of my favorite properties, the constant term property. So let's do an example of that one as well. So the idea with the constant term property is you have a starting value of m. So m will be a number all the way up to n. And then you're adding some constant. So there's no I in this expression. And what this constant term property tells you is that the final outcome will be n minus m plus 1 times c. So let me show you that this is really the case with an example. Do you remember this example? I is 2 all the way up to 5, and then here we have a 10. Okay. So what you will see is that the first value of I will be 2, right? Then the I will be 3. And then the I will be 4. And then the I will be 5. And then the sign in between will be pluses. And then if I is 2, I get a 10. If I is 3, I also get a 10. If I is 4, I get a 10. And if I is 5, I get a 10, right? Okay. So I basically use the index to know how many 10s I get. Okay. So here I get 4 times a 10, which is 40. Okay. But you can imagine that here it was doable with this method that we start this session with. But if I would, for example, have a 50 here, it would be a lot of work to write this all out. So you want to have some sort of property to speed up the process. And that's this property. To get this 4 here, the 4 times 10, I could also have used n minus m plus 1. Because what's my n in this case? The n in this case is 5, right? So I could also fill in 5 here. The m in this case is this 2 here. So to get this 4, I don't need to write this all out. I could also use the trick 5 minus 2 plus 1 is 4. So 4 times the 10. And that's a way to speed up the process. Okay. So let me give you another example. The summation of I is 2 all the way up to 101. And then you have a 5 here. Feel free to submit your answer via Zoom. Arnoud is really fast. Yes, that's correct. So everybody that submitted his answer gave me the correct answer. Yes, everyone had it correct. So indeed, you write down n minus m plus 1 times c. So that's 101 minus 2 plus 1 times 5. And that's 100 times 5 is 500. Perfect, guys. Okay, so this is a really nice property. So let's do the next term here. The last property you need to know is the telescopic series. This one is maybe a bit more difficult to recognize, but let's have a look. Okay. The property is defined like this. You start at some value m, you go all the way up to n, and the structure is really difficult to recognize, but I will give you a few examples, and then this one gets really clear. You have xi minus xi minus, xi minus 1. And what the telescopic series predicts is that this will eventually be xn minus xm minus 1. Okay. We're going to see if that really is the case. So here's an example. So let's say we have this summation here. It starts at 2. You're welcome, Wusi. So we start at I is 2, and we go all the way up to 5, for example. And then the structure is like this. You have, I don't know, I with the power of 2, and then minus I minus 1 squared. So you can recognize it because we have some expression called xi minus the same expression, but then with I minus 1. You see that? And you subtract it from each other. That's how you recognize the structure of the telescopic series. And what it predicts is that I get the expression with the n filled in minus the same expression with the m minus 1 filled in. And I will show you that. So let's first do it in the method we started the session. So you write down I is 2. Well, in that case, you would get 2 squared minus 1 squared, right? There you get I is 3. There you get 3 squared minus 2 squared. I is 4. There you get 4 squared minus 3 squared. And here I need to make some extra space. So 1 second. And then you get I is 5, which is 5 squared minus 4 squared. Okay. So here's what the rule predicts. Everything will cancel out except for the xn term and the xm minus 1 term. So let's have a look. This 2 squared will cancel out with this negative 2 squared. This 4 squared will cancel out with this negative 4 squared. This 3 squared will cancel out with this negative 3 squared. And the only terms that we have left are this negative 1 squared and this positive 5 squared. All the other terms cancel out. And that's what the rule predicted, that you get 5 squared minus 1 squared. The xn term minus the xm minus 1 term. And that's the telescopic series. So in the future, you can do it as follows. So here we go back. So this was what we started with. In the future, you can remember, okay, this term, I will insert a 5 here. That's the 5 squared here. In this term here, I will insert my lower boundary. Now you get 2 minus 1 squared, which is 1 squared. And that's how you do it. So you fill in the n in here, and you fill in the m in here. And then you're there. That's your final answer. So we will get 25 minus 1 is 24. Okay. So here's another example. So here is an example why you would want to learn this rule. Oh. So summation I is 3 all the way up to 100. And then I squared minus I minus 1 squared. Okay, here you will see why the rule is really helpful. If you would write it all out, you would get almost 100 terms, right? So that would be way too much work. But if you know this rule, you can figure out your answer pretty fast. So send me your answer. You can send it via Zoom if you think you know it. I think you made a small miscalculation as this, but I think you understand it. The rest of you that submitted his answer had it correctly. Yes, very good, Thomas. Yes, very good, guys. I get a question, is it always something with squared? No, not always, but most of the time it's very helpful to use this rule when you have something with a power. But I will show you another example of when you can apply this. Okay. So indeed, we fill in the n, so we get 100 squared minus the lower boundary minus 1, which is 2 squared. And then if you fill this into your calculator, you get 996. Perfect. Okay. So let me show you a third example. Maybe I can shrink this a bit. Let me try it out. Okay. Here's a third example, so that you also see a different sort of function. I is 2, and here we will put a 5, and we get 2 with the power of I minus 2 with the power of I minus 1. Again, you can submit your answer. Bjorn is really fast. Arnold as well. I get some different answer from Jelte. Think Bo and Denise made some miscalculations. Perre has it correctly. Sophia has it correctly. Vera, would you like to help me?
Yes, I can.
Okay, so we first fill in the upper boundary in here, right? So then you
Yes.
get 2 with the power of 5. What do you subtract?
-2 with the power of 1.
Yes. Well, this here is 32. You can fill this into your calculator, you get 32. And what is 2 with the power of 1?
2.
Yes. So what's your final answer?
30.
Very good. I thought you submitted something different, but
Yeah, I had, because I had a miscalculation with the 2 with the power of 5. I didn't have my calculator with me.
okay. No worries.
Even
But
though
very
I had
good
to.
pick. Thank you.
Yeah.
Okay, so those are all the properties. So you also have some properties for the products. You will see that those are very similar. You will definitely recognize this structure here. Okay. So let's go and make some exercises. Some of them are doable, but there are a few exercises really difficult. So don't feel bad if you will have some difficulties with that. I think this one is pretty doable. So you can again submit your answer. That's correct, Arnoud. Very good, Niels. And by the way, I think there are like 5 exercises or something. After those 5 exercises, we will have a small break. I think almost everyone had it correct, and I think Vera made a small miscalculation again. Yes, everyone has it correct. By the way, the real classes are in smaller groups, obviously. Then we only have something like 15 to 20 people in a class. And then I can just walk around to see what you guys have and how far you are. Thomas, would you like to help me with this one? So which property did you apply here, Thomas?
I used the first one, so I just put the 2 in front of the summation instead of behind it, and then I just 1 plus 2 plus 3 plus 5 plus.
May I say one thing? You could use homogeneity, but actually here you should recognize that you have to apply the constant term property. The constant term property. Do you remember that one? So that was, if you have this structure, I is m, all the way up to n, and you have a constant, then you can write it down like n minus m plus 1 times. Do you remember times what?
Times 2.
Times c, yeah, and that's the 2 in this case. So here you will have an n of 10, an m of 1, plus 1. And you already said it, the c is 2. So what do you get?
Just a question. Is it still good to do the homogeneity, or is it only the constant term?
Yeah, so if you would apply homogeneity, you would get something like this. Like this, right?
Okay.
But yeah, I wouldn't do it. Then you get 2 times 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 all the way up to 10.
Yeah, that's what I did.
You would also get 20, of course, but yeah. Okay. So did you now see what went wrong, Thomas?
Yeah. Thank you.
Very good. 20. Okay. Then the next exercise. So here you can also see it. This one is already a bit more difficult. My first question to you guys is, what kind of property do you think we have to use? And then start by writing down that property. And then try to figure out the answer. It is a bit more difficult. I get some water real quick. Do you guys already know which property you need to use? Yes, very good. You need to apply the extending terms property. So you can start by writing down the extending terms. And Arnold, really good. You have the correct answer. Okay, so I will give the first hint. So you do need to apply the extending terms property. this. So this one is difficult, right? Don't worry if you are a bit stuck. It's normal. Oh, if I could back to the slides with the properties. Sorry, I that you had to wait a few minutes. So here's the slide with all the properties. 1 second. So here's the extending terms property. I also submitted the summary in the WhatsApp group if you want to see it again. Can I go back to the axiom question? Okay, you're welcome. Okay. So let me give you the first hint. What do you think the n plus m is in this question? N plus m. It needs to be a high number and high upper boundary.
$45.
Yes, 45. So this one should be 45. Then here, this is the n. What do you think the n is? That's a low upper boundary.
$23.
23. Then normally we should have what kind of number here? It's 24, right? Normally. But we don't know the summation with 24. We only have the summation that has 23 as the lower boundary, right? So does everyone understand why I need to put a 23 here instead of a 24? Because that's what is given. And what kind of number will I put here?
$45.
45. Okay. Do the two sides balance, or do I need to make a correction?
Correction.
Yes. How can I make a correction? Should I add or subtract anything?
Subtract 23 or
Yes, very good. Subtract the x23. So here's what happens. I want to have all the terms from 1 to 45, but the 23 is counted twice. So to correct for it, I need to subtract the x23.
And
Could I explain? Yeah.
why don't you just say I is 24 instead of 23?
That's a good question. Good point. So they give me this summation here. They say that's 78. I don't know what the summations would be if I would start with a 24. That was not given in the question. So I had to be a bit more flexible. So they only
Oh,
give
okay.
it
Yeah.
when it's
Okay.
a 23.
Yeah.
Okay. And now I have everything I need, because what is the value of the first summation? the value of the first summation here?
34.
34. And the second one?
78.
Yes. And then this x23 is?
6.
Very good. And then you get the final answer. I think only Arnoud had it correctly and really fast. So don't feel bad if you didn't have it. But it is 106. Is this one clear for everybody? Do you get what I did here? That's the most important thing. If you didn't figure it out yourself, don't feel bad. We're just getting started with this course. But as long as you understand what I did and why I did it. So to summarize, I will go through the steps one more time. You first need to recognize that you can use this extending terms property. Then you should recognize that you cannot apply it exactly how it should be. You are working with a 23 here and a 23 here. That means that you took the 23 twice. So to correct for it, you subtracted 23 so that the both sides balance, and then you can calculate it. Okay. Is this clear for everyone? No questions? Then I go to, so the question is, why do they give us the x of 24? Just to confuse you, we didn't use the x of 24. Good point. Yeah. It's just there to confuse you. Any other questions? Yeah, x23 is 6 indeed. Any other questions? No? Okay. Okay, this is a really difficult exam question. I never saw a single student that could figure it out. I never saw one. And I am teaching this course for more than 5 years. And I never had a student that could figure it out. So if you don't know how to do it, don't get frustrated. You're not the only one. It's just a really difficult exam question. I always say, if you can live with a 9.5 for your exam, then you don't have to know this one. But if you want to have a 10, well, then you of course want to figure it out. So I give you some time to read it and to think a bit about it, but then I will probably just solve it myself. It's difficult, right? It's not 2a with the power of 2. Okay, let's go through it. Okay, what do we want to know? We want to know this summation here, right? I is a, all the way up to 2a, and then I. So let's have a look how this summation looks like. So nobody submitted the correct answer, but don't feel bad about it. At least well, maybe Arnaud gave me the correct answer. I'm not sure. I don't know. I'm not sure, but we will see. Okay. So what we're going to do is I'm first going to visualize what this thing is saying. So it starts at a, then it goes to a plus 1. Maybe I can type it with the text editor if you find that okay. So it starts at a, then it goes to a plus 1, and then it goes all the way up to 2a. Everyone agrees? So for example, if a is 3, for example, then it would look like this. 3 plus 4 plus 5. And where does it stop? At which number does it stop?
Six.
Yes, very good. So in this case, it would, for example, be 18, right? If the a would be 3. That's what we, for example, want to calculate. But now we want to calculate it for each single a. So no matter what a you choose, you get some sort of expression, some formula for it. Okay. So can I erase this thing? You now have some idea what we want to calculate? Okay. So here's the method you can use to figure it out. What you do is to calculate it, you need to apply this thing here. He says, if your summation starts at 1, then you can apply this formula, but only if it starts at 1. So we have to come up with a way to get a series that starts at 1. And here's the trick. So this is the difficult part. To see it yourself, you have to be a bit creative. You start at 1 plus 2, all the way up to a minus 1 plus a plus 1, all the way up to plus 2a. So here's the long series, you see that? And then you subtract minus this short series. 1 plus 2 plus point a minus 1. Notice that this is exactly the same, because those terms will cancel out with each other, and then I'm left with what I want to keep, right? So everybody agrees that this is the same. Now we have two series that start at 1. That means we can apply this trick here. Okay. So from here on, it will become less difficult. This one was the difficult step to see. Okay, so here we go. Since this series here starts at 1, I can write it down like this here. Then what would be the end of this long series? What would be the end of the long series? So this is all the way up to 2a, right? minus. Okay, I will ask another question. What will be the end of this second series here that I subtract? This series here. What's the end there?
A minus 1.
Yes, very good. Okay, so we can write this summation here like the subtraction of those two summations. Everybody agrees with that. If you didn't came up with it yourself, don't worry. But does everybody agree with that? Okay. Now, we can apply this fraction here. What is the end of this first summation? This
2a.
first summation. Yes, very good. Times n plus 1. So times 2a plus 1 divided by 2. That's the first summation, right? Minus the second summation. What is the end of the second summation?
A minus 1.
Yeah, very good. And then times n plus 1. And what is n plus 1? N plus 1?
A.
N plus 1 will be a, because n is a minus 1. And then if you add plus 1, it cancels out, so you're only left with a. Okay, so let me know if you see why this is just a. And here we go. We are getting something. So we now have this formula here, and now we only need to simplify it, and then we have the final answer. Okay. So since the denominator is the same, I can put it in one single fraction. And here we go. 2a times 2a. What is that?
Four a squared.
Yes, very good. 2a times 1.
2a.
Very good. A times a, but notice the minus.
Minus a square. And minus.
Yes. And here we get minus 1 times a. So do we get plus a or minus a?
Plus.
Yes. And then we can do 4a squared minus a squared to get this 3a squared. And then 2a plus a to get 3a. And this is our final answer. Very difficult, right?
Don't you have to simplify any further?
You can get the 3a and the 2 out of the bracket, so you could simplify it like this. If you want. But according to the answer model, this one, what I wrote down here, was also correct. Okay.
I have a question.
Mm-hmm.
How did you come up with a minus 1 plus a plus 1?
How did I come up with what?
With that there, a minus 1 plus, yeah.
This here?
Yeah.
Okay, so what I saw is that I need to have a series that starts at 1. So I had to come up with a way to get a series that starts with 1. And then this was the trick. So this one didn't start with 1, and therefore I took 2 series subtracted from each other that do start at 1. That's just the trick. You can also apply the extending terms here. So if you look at the solution in the summary, I use the extending terms property.
Okay.
But it is pretty difficult to see that step.
because at the end you're just like putting the 2a, which you can find in the example in the question, but how can you find then the a minus 1?
Yeah, so that's what so the idea was that I want to keep this a, right? Because it needs to start at a. So I go all the way up to a minus 1, because if I would go to a, I would lose the a, and I don't want that. So that's why I stopped 1 earlier.
Ah, okay, I get it.
Okay. And if you look at the solution from the exam, here you can sort of see it. I don't want to clear my solution, but here I use the extending terms property. That's the intention of the action question. But I thought this is a better method. So I think it's difficult, but don't worry. As you sort of get my steps, it's already very good. I already said if you want to get a 10, you need to have it correct. But if you can live with a 9.5, then it's also fine. Then you can skip this one. Okay. Last question, and then we have a break. For this one, you can just use the method at the start of the session. You don't have to use any property at all. I did it in the solution so that you can practice with the properties, but I would not recommend to use them. So don't use the properties for this one. Just try it yourself. Bo has it correct. The rest of you guys made some small mistakes, I think. So I want to say that it could be the case that you have some letters in your final answer. Thomas, the 39 that you got is not correct. You made a small mistake there. Zoom user, I cannot see your name. The minus for J is not correct. George, would you like to do it together?
Yes, it's correct.
No, it's not correct, but we will look what went wrong. So maybe we can just go through the steps. So 2 plus 3i minus 4j. Okay, what's the first value that I will be?
3,
Yes, and then it will be
4, and 5.
4. Yes. Sorry, the writing is always a bit difficult, I assume. And what kind of sign will you put in between?
Plus.
Yes. Okay. Here I get 2 plus 3i. What is 2 plus 3i?
11.
Yes. Minus 4j. Notice that the j is a constant, right? We cannot fill in the j.
There is 14 minus 4.
Yes.
Plus
4j, right?
4j, yeah. And 17 minus 4j.
Yes. Okay. What is 11 plus 14 plus 17?
42.
42. And then negative 4j minus 4j minus 4j?
Minus 12.
Yes. Very good, George. Is this clear for everyone? Because then we will have a small break. Any questions? So why can't you use n minus m plus 1? Well, for the 4j, you can use the n plus m minus 1. And also for the 2, you can use the n plus m minus 1. But I would not recommend it. So here in the solution from the summary, I showed the properties, just not because I think you should do it on your exam, but because then you can practice a bit with the properties. That's why I included it. But yeah, I wouldn't use this on your exam, this solution. So what I just wrote down here, that's what I recommend. So not the solution here, but this solution that I just wrote down. That's better.
Don't we have to rearrange the 42 equals to 12j and find the j?
No, it's not possible to find the j. So this is the best you can do. 42 minus 12j.
But
Okay.
I can't find it. If I put 42 equals to 12j and make 42 divided by 12.
So you say j is 42 divided by 12?
Yes.
You can only do that if I would say that this summation is 0, for example. But that's not what they said. We don't know what the summation will be.
Okay.
Shall we have a break then, guys? No questions?
Yeah.
So let's see. Shall we do 10 minutes that we continue at 11.35?
Okay.
All right, see you then, guys. Vera, do you mean this answer?
No, the answer you just wrote down from.
Oh, I'm sorry. I
No.
already
Oh, okay.
erased
Doesn't
it.
matter.
Okay. I'm sorry,
Thank you.
but I did record it, so you can watch it back. I'm sorry.
Okay. Thank you.
You're welcome. Okay, are you ready to continue? So I now read the question of Thomas. So you asked if I did send a summary. Let me see. I think I'm. I might need to send it again. Maybe you were added after I sent the summary. So I will send it again. Do you now see it, Thomas? You're welcome. Okay. So let's continue. So sometimes why didn't we simplify 42 minus 12j to 3 minus 3,5 minus j? The reason for that, guy, is nobody said that the 42 that this nobody said that this was equal to 0. Nobody said that. So we cannot divide it by 12 or something. That's not possible. This is just the answer. If, for example, the j is 1, we don't know it. But if the j is 1, for example, then the outcome would be 30. But if the j is 2, then the outcome would be even lower, right? So then the outcome would be 80. So we don't know what the j is. So we only can say that this is the answer, 42 minus 12j. Okay. Okay. So in the previous cases, we got a summation and we had to figure out the outcome. But now we're going to do the opposite. So we start with a series and you have to come up with a summation. And you can basically follow a step procedure for tutorial questions like this. You start by taking the final outcome, which is I, N, B, and J. And then you replace the N with an index sign of your choice. So for example, I or J, but we already used the I and the J. What's the next letter in the alphabet after the J? It's the K, right? So let's replace the N with K. So this is the first step. We put a summation sign in front of it. And then we have K as the index letter. And then the first value that this series will be is 1, right? So K is 1. And then it goes all the way up to N. So to summarize the series in a summation sign, it's like this. So here you go. This is the summation sign that corresponds to that series. So you take the last term, you replace the N with an index sign, and then you look what is the starting value, which is 1, and then you're basically there. So let's do another one. So 4 plus 8 plus 12 plus 6, all the way up to 4n. So I start with the final term, the 4n, and then I replace the n with a sign of choice. So could somebody say letter? For example, the I, right? Here I didn't already use the I, so I can just take it. Then you look, what should be the first value for I? Because I want to get this 4 here. What kind of I do I need? Do I need an I of 1, an I of 4, or something else? What kind of I do I need?
1.
Yeah, 1, right? Not 4, because now you want to get 4 times 1 to get this 4. And then all the way up to n. So those are some tutorial exercises. They're really easy. You can just apply this step procedure. But it doesn't always go all the way up to n. So let me do some examples that are different. Okay. What if you would get this series here? 3 plus 6 plus 9 plus 12. Come up with a summation here. What kind of expression do I have? Anyone knows?
3i.
Yeah, 3i, very good. And then here you would get 3 times 1, right? 3 times 2, 3 times 3, 3 times 4, right? So what is the starting value for I?
1,
And the ending value?
4.
Very good. Let's do another one. A more difficult one. 15 plus 20 plus 25. What's the expression we could use?
5.
Yes, 5 what?
Oh, 5i, for example.
Yes. And then what's the starting value?
3.
3. And the ending value?
5. 5.
Yes. So here we get 5 times 3, 5 times 4, 5 times 5. So 5 is the ending value. Okay. Last one. Do I use a summation or product operator?
Product.
Yes. What's the expression, you think? What's the
3i.
expression? The 3i?
Yeah.
So 3 times I, you say. That's not correct.
Oh.
I'll give you a hint. 3 with the power of 1. 3 with the power of 2. 3 with the power of 3. Do you agree with that?
Oh, yeah.
So what is the expression?
3 and then the thing above.
Yes, with the power of 1. What is the starting value for I?
1,
And the ending value?
3.
Very good. Okay. Is this clear for everyone? Yes? Okay. Then I want to show you something else. This is how you solve double summations. Okay, let me show you. So let's say that we have I is 1 all the way up to 3, and j is 1 all the way up to 4. And we have the summation I times 3 with the power of j. Okay. How do you solve a double summation? Well, this here is the summation on the inside. So if you follow the mathematical order, you normally first calculate the summation on the right, and then you get some value, and then you solve the left summation. That is the natural order. Okay. There's one exception, but this is how it normally goes.
Is it then maybe useful to put it between brackets if you're if you do it?
Yeah, you could do it like that. So this is
Oh, okay,
actually
yeah.
what.
Yeah.
Okay, so how do we do it? You first copy the left summation, because that will be the last step. And then you solve this summation, like we did at the beginning of this session. So j is 1, j is 2, j is 3, j is 4. And because the right summation is a summation and not a product operator, we're going to put pluses in between. Okay. Here I get I times 3 with the power of 1. I times 3 with the power of 2. I times 3 with the power of 3. And then here I times 3 with the power of 4. Now we want to simplify this a bit further. What we see is that we have 4 terms, but each term has an I in it. So we can get the I out of the brackets. So I put the I out of the brackets, and then I write down 3 with the power of 1, plus 3 with the power of 2, plus 3 with the power of 3. And maybe somebody can already fill this into his calculator, because this will be a number of it. Could somebody fill this part in his calculator? You get 120 indeed. So we get I is 1, 120 I. Like this. And now you've reduced the double summation into a single summation. And this will be pretty easy, right? This is just 120 if I is 1, plus 240 if I is 2, and then 360 if I is 3. And if we add this together, what do we get?
720.
Very good. Okay. And notice that the last summation was a summation, and therefore we have pluses here. Okay. Let's do another example. Did you guys have the time to write this down? Okay. Then we go to the next one. Almost the same question. Oh. Okay, so I got a question. I don't understand what happened with the summation with 4 on the upper side. So what we did here, this is the summation with 4 on the upper side. We just copied the summation here on the left, and then we solved the summation on the right like we always would do. Do you see what I did here? Okay. Any other questions? No. So I'm going to basically give you the same exercise. but now I change the right sign in a product operator to see what happens. Okay. So who likes to help me? The first thing I do is I copy the left summation, right? Because we always start with the right one. However, there's one exception. I will show that later. Okay, so we go for J is 1, J is 2, J is 3, and then J is 4. Okay. What kind of sign will there be between the terms? A time sign or plus sign?
Times.
Yes. That's the crucial part from this example, that because the right is a product operator, you will use time signs here. Okay, so you get I times 3 with the power of 1, I times 3 with the power of 2, I times 3 with the power of 3, I times 3 with the power of 4. Now we're going to simplify it again. So I just copy the summation sign, not going to use it yet. Okay. Let's see. I times I times I times I. What will that become?
Or I.
I to the 4th.
Yeah.
And then we have 3 with the power of 1, 3 squared times 3 cubed times 3 to the 4th. What will that become? Do you know the rule? If the base is the same, you can add the powers, right?
Yeah, so that's 10.
Yes, 3 to the power of 10. And now again, we have reduced the summation sign into the double summation sign into a single one. Okay. And now you just do it how you would always do it. You start with I is 1, I is 2, and then the I is 3. Okay, very important, because now this left one is a summation sign. I'm going to put pluses here in between. And then you get 1 to the 4th times 3 to the 10th. 2 to the 4th times 3 to the 10th. And 3 to the 4th times 3 to the 10th. And what will you get out of this? What will you get? So from here on, you can just plug it into your calculator. You can even get 3 out, 3 with the power of 10 out of the bracket. But what do we get? Did somebody submit the answer? Because I honestly don't know it. $5,786,000. And what did you say? 802. Did everyone get this? I see that Perre got something different. I think you made a mistake somewhere. But this is indeed the correct answer, I think. Okay. Yeah, no worries. Okay, here's another one. There's one exception, that's that this is one of your tutorial exercises. Here's the thing. Normally you have a number here, right? But here,
I'm sorry,
you're
what
not
was the
having that.
answer?
The answer was something like 5,786,000. It's also in the summary, we can have a look.
Oh, okay, thank you very
Here
much.
you can see it. Yeah, you're welcome. Here we go. Okay, so normally we would have a number here, right? But now I will simply put a J here, and here I will put in. This one is the most difficult double summation in your tutorial exercises. Okay, what happens here is we normally would like to start with the right one, because that's the one on the inside. But we cannot do that because we don't know the upper value. So here we are forced to start with the left one, with the outside summation. So, okay, that's fine. We will just do that. J is 1, J is 2, and then J is 3. So we start with the left operator. What kind of signs do we get in between then? If we first start with the left one.
Plus.
Yes. So here we get plus. And then we're going to fill this one in. So the product from I is 1 all the way up to 1. And then here I is 1 all the way up to 2. And here I is 1 all the way up to 3. Okay. So the mathematical order is that you normally start with the right operator and then with the left, right? Because the inside will be calculated first if you look at the mathematical order. But here that was not possible. So here we were forced to start with the left one. You normally don't want to do that because then you get this 3 times that product, right? But here we didn't have any other choice. So here we had to do it. Okay. So notice that the lower and the upper boundary are the same. So here in the left one, you just get 1 here. So this product operator would just become 1. This one here is pretty easy, right? What will this product operator be?
2.
1 times 2 is 2 indeed. And what will this product operator be?
6.
Yes, 6. So we get 1 plus 2 plus 6. What's the final answer?
9.
Yes, very good. And that's if you have that strange situation where you get some strange upper boundary. Okay. Is this clear for everyone? Yes? Okay. Then something else. A really typical situation is that you get some table here. So let's say that I have this table. So here, it's a bit strange maybe, it's the A11. Here you get the A12, the A13, and the A14. And here you have the A. Yeah, maybe I make it a 2 times 3 table, that's fine. to keep it a bit short. And here I have the A21, the A22, and the A23. This is my table, right? Okay. And let's say the values from the table 1, 0, 2, 3, 1, 0. Okay. Question is, what is so you never saw this before, but what they're actually asking is add up all the elements from the table. Let me show you. Because what they're actually asking here is, we can figure it out by first solving the summation on the right. So we copy the left summation. I is 1, 2, and then you get j is 1, j is 2, j is 3. What kind of sign do we put in between?
Plus.
Plus. So here I get AI1, AI2, AI3. And now I will solve the left summation. So I get I is 1 plus I is 2, right? A11 plus A12 plus A13. And then this thing plus A21 plus A22 plus A23. Do you guys agree that this is what they're basically asking? If they say, what is this summation? They're literally asking to add all the elements of the table. Do you guys agree with that?
Yeah.
And that's what I want to show you, because this is a really typical situation. So if you ever want to add all the elements from a table, you can use a double summation. That's the insight here. So what's the answer? 1 plus 0 plus 2 plus 3 plus 1 plus 0. So if I add those 6 numbers together, what do I get?
Seven.
That's the answer to this question. But the learning objective is that you now understand that you can add elements from the table with a double summation sign. That's what you now learn. And then notice that this first summation goes up to 2 because you have 2 rows. And the third summation goes up to 3 because you have 3 columns. I could also have switched the 2 summations. That's also fine. Okay. Is this clear for everyone? This was just an example. Okay, then here I have an excellent question. Take your time to read it. So you can type done if you think you have the answer. Yes, it's so Thomas, indeed, we will assume that. Okay. So let me explain it. So what we have here is we have a solar panel, and notice that is a table, right? So it has 5 rows. So rows is 5, and the columns, the number of columns are equal to 7. So we have 35 cells in total, right? And each cell produces a particular amount of energy. And we want to calculate the total amount of energy, which is the summation of all the 35 cells, right? So we make one summation that goes through all the rows. So what kind of number do we think here, if this summation is meant for the rows?
5.
5. And then this summation is meant for the columns. So I make 7 columns. And then this is your answer. Using those 2 summations, you can add all the cells together, just as in the previous case. Is this clear for everyone?
Yeah.
Okay.
Why you put one down?
The question.
Yeah.
Does it matter if the 7 is the right or the left? Okay,
Yeah, you can definitely switch the 2 summations. And if you define j as the rows and I as the columns, then you could also switch the 2 numbers. That's
Okay.
correct. Yeah. Okay. Any other question? But I have to say it is in this course, they always use the number on the left for the rows and the number on the right for the columns. So therefore, it might be that they don't allow it in this course. Yes. But
Okay.
And it's
so here's the
also
answer model.
and it's also in the order of first rows and then columns. So if it
Yes.
if it was switched, then then it would be the other way.
Yeah, exactly.
Oh, okay.
Any other questions? Okay. And you will also encounter this in week 4 in when we are going to discuss matrices, which are basically tables. Then we also need this trick here to add all the number of cells together. Then you also use double summation sign. So it's important to remember. that was it for the summation part. Shall we do some logarithms? What do you guys think about logarithms? Do you find it difficult?
A bit.
Let's do a nice recap. So let's say we have log 3, 9. Then this 3 is my starting number, and the 9 is my ending number. And what I want to do 3 with the power of something to get 9. What is that something? 3 with the power of something to get 9.
2.
It's 2, right? Very good. Log 4, 16. That's also 2, right? Because 4 with the power of 2 is 16. Log 2, 8. What is that one?
3.
Yes, very good. Those are the basic situations. So that's what a logarithm does. It gives you the power to get from your base number to your end number. Let's look at some special cases. What if I have log 4, 4? So my base number is the same as my final number.
That's just 1, right?
Yeah, pretty good.
Okay.
Log 2, 2. That's also just 1, right? So what is the insight? If your base number is the same as your final number, you will always get 1. Log log 4, 1. So what if I give an input of 1? What do I get out of this? 4 with the power of something is 1.
0.
0.
Yeah, very good. Log 2, 1 is also 0, right? So each time you insert a 1 in it, the outcome will be 0, because something with the power of 0 is 1. Okay. Let's see what happens if I fill in a number smaller than 1. So for example, log 2 and then a half. What do I get?
-1.
-1, right? Because 2 with the power of -1 is a half. Everybody agrees with that? 2 with the power of -1 is a half. Log 2 1/4. What would that be?
-2.
Yes, very good. Because 2 with the power of -2 is 1/4. So the outcome of a logarithm can become negative. Can I also insert a 0 in it? Is this possible?
No.
No. I get an error because I cannot never do 2 with the power of something to get 0. So this equation here has no solution. There's not a single exit I can find to get a 0 out of it. Okay. Can I insert negative numbers inside my logarithm? Something like this. Is that possible? Is this possible?
No.
No. This also doesn't have a solution. There's nothing you can fill into the power to make the exponential function negative. So it has no solution as well. Okay. So let's see inside here. The input from a logarithm has to be positive if you fill in a 0 or negative number, you get an error in your calculator. That's what you can remember. Okay. Then a few extra things. The first thing is the E. E is a number, 2.718. It's an irrational number, just as pi. And we find the E such a special number that we gave it its own logarithm. So if you see log EX, so the E is the base number, we call it ln x because it's such a special number. So my question to you guys is, what if I have ln E? What do I get? Anyone has an idea?
1.
Yeah, because here I'm actually saying log E, E, and then the base and the n number are the same, so I get 1. Very important to remember, ln E is 1. Okay. Is this clear for everyone? Then if you look in the summary, there's some nice tricks you can use. So for example, if you want to calculate log 416, you already know it's 2, right? The idea is that on your calculator, there are only 2 buttons. You have the log button, which assumes a base number of 10, and you have the ln button on your calculator. Only 2 buttons for logarithms. But what if you have a different base number than 10 or E? How can you still fill it into your calculator? Then you can use this trick here. So you say ln your n number divided by ln your base number, and then you get a 2. So if you want to use a different base number than 10 or E, you can apply this trick here. You can try it out. ln 16 divided by ln 4 is 2. Because 4 to the power of 2 is 16. Can I explain ln E? Yes, of course. So we said that log 4 is 1. Because 4 with the power of 1 is 4. Log 2 is also 1. Log E is also 1. Because also here the base number is actually an E. And the n number is an E. So you get a 1. Do you understand that? So indeed, it's a special case where the base number is E. Yeah. Okay. So here's another one. How do we know log becomes ln? Do you mean in this trick? It doesn't have to be ln. It can also be an other logarithm. Here, I will show you. Okay, so let's say that we want to know this logarithm. Here, I don't know what it is. Because the number is pretty high. I don't know what it is. So here I can use the trick ln n number divided by ln 3. And if you plug this into your calculator, you will see it's 5. Because 3 with the power 5 is 243. But it doesn't necessarily has to be an ln. You could also have used log 10, for example. Here, log 10. You also have a button with log. Then they actually mean the log 10 button on your calculator. If you apply that consistently in the numerator and in the denominator, you will also see it works. Here, give it a try. Log 243 divided by log 3. So it doesn't matter if you use ln or log 10, they both give you the correct solution. So in general, it always works. That's what they're saying here. You can use the E here, or you can use the 10 here, or any other number. Okay, is this clear for everybody? Yes? So here are some other tricks, some other rules you need to know. So those rules you're seeing here, we already discussed. And then you have those two rules here. What you're seeing here is that the logarithmic function and the exponential function are each other's inverse, so they cancel each other out, just as the multiplication is the inverse of the division. So if you put the exponential function inside the logarithm, they cancel out and you are only left with x. And what you're seeing here is that they insert the logarithm inside of the exponential function, and then it also cancels each other out because it's each other's inverse. And then you have some extra rules here. Here you see that if you take the log of an exponential function, the power falls in front of it. Oh, I see something in the chat. For the first one, we have x because a makes 1, so 1x. Could you elaborate on that? I think I don't get the question. For the first one, we have x because Okay. Okay, yeah, I think you're right. I think I see what you're doing, and I think that's correct. That's one way you can look at it. Okay. Okay, so I think we were here, right? So the power falls in front of it, and then you're left with n log a. So for example, if you have ln x squared, you can write it down like 2 ln x, for example. That's what the first rule tells us here. Okay. Then here you have some other thing. If you have two logarithms with the same base number, they both have the c as the base number, and you add them together, you can multiply the input, so you can get a times b. And here, if you subtract them, you can, and they have the same base number, you can divide the inputs on each other, a divided by b. And then this one was the trick that was helpful to calculate something with your calculator. So if you had log 3 243, you want to calculate this, you could, for example, do ln 243 divided by ln 3 to get 5, right? That's a trick to get your answer here. That's what you're seeing here. Okay, so we're going to apply the rules you saw on this slide with this axiom question. And then we call it a day. Then we're done for today. So take your time to submit the answers. And then this will become the last question. I will copy it, and then I will open the rules. The ln1 part from your answer is not correct, Shelta. Very good, Vera. I think indeed that's the correct answer. I think you're missing something, Brady. You're missing the X. Very good, Bo. Very good, Arnoud. And Thomas, would you like to do it together? Maybe I can help you a bit.
To be honest, I have no idea how to do it.
Yeah, no worries. So I will tell you the trick that you can first apply. So the first one is you can apply this one here. What would happen then? Then I would get ln, open bracket, 5e with the power of 3x, and then? If you apply this trick here, a minus b becomes a divided by b, right? So this is your a, and then I divide it by what?
You asking me the question?
Yeah, I'm asking you,
Oh,
Thomas.
sorry. By 5 then?
Yeah, very good. What happens with the 5s? What happens with the 5s? I have a 5 in the numerator and I have a 5 in the denominator.
So it's just ln e3x.
Yeah, pretty good. They cancel out.
Okay, thank
Here
you.
there are two ways. Sorry?
I should just say thank you.
Oh, okay. And then we have this here. And here I think there are multiple ways to simplify it further. One way that you could look at is you can use this structure here, right? That you say the logarithmic function and the exponential function cancel each other out. So you are left with 3x here. That's one way to think of the problem. Another way, which takes one step extra, is that you say, I will apply this trick here. Then the power falls in front of it, like this. What do you remember what ln e was? Anyone remembers what ln e was?
1.
Yeah, ln e was 1. So then you're left with 3x. That's another way to do it. As long as you get the 3x. Is that clear for everyone?
Yeah, clear.
All right. Perfect, guys. Then that's it for today. And then the next session I will pick it up from here. So I really enjoyed it. Have a great weekend, guys.
Thank you. You too.
Thank you very much. Bye
Thank
bye.
you.
You're welcome.
Thank you. Bye.
Bye.
Thank you very much.
Thank you so much.
I had